Hi, welcome everyone. We are extremely stoked for the attendance at this hour. I know everyone's probably wanting to grab their rolly bags and get out of here. So we debated the merits of just spending the 35 minutes that we have today for just Q&A, but instead we decided to go with kind of a middle ground and really narrow down the slides, give a minimal demo, and then give a lot of time for discussion because I'm sure there's plenty of questions based on what my colleagues at the booth have been saying. So a quick introduction. I'm Brandon Chavis. I'm the product manager for EKS.
And I'm Arun Gupta. I'm a principal open source technologist responsible for the open source containers and serverless strategy.
So yeah, let's go ahead and get started.
All right, cool. We're going to get started. Brandon doesn't have a Twitter handle. I do have a Twitter handle. So it's all right. You can tweet me and I can pass the message to him.
I don't know how to use computers.
Okay, yeah, that's true. Well, you're a product manager. You don't code. So what is EKS? EKS is a managed Kubernetes service from Amazon. We introduced this at reInvent last year. What do we get as part of this managed service? If you look at Kubernetes cluster, it consists of two pieces. One is a control plane, which is where your masters are running, and then there's a data plane where your worker nodes are running. Worker nodes is where your containers are running. So as part of EKS, which is Elastic Container Service for Kubernetes, that's what the EKS stands for, we give you a managed control plane. As part of that, it's a fully highly available setup. What that means is we are running, if you're picking a region, say US West 2, where the limited preview is available today, then when you are asking for an EKS cluster, if you do have access to limited preview, then we spin up a master in a highly available configuration. That means we're running it in multiple availability zones. So to be specific, 3 availability zones in a region. In addition, your HCD is also running across 3 different availability zones. That's fully available. The HCD itself is encrypted, backed up, and all regularly done for you so that you don't have to worry about it. And we also provide you full upgrades in the sense that if there are Kubernetes versions coming up, newer versions coming up, we provide you an option of automatic upgrades or manual upgrades. And then also in terms of, if you look at how the master need to be created, if you look at the Kubernetes documentation, it talks about the instance type that should be defined based upon the number of pods in your cluster. So the worker instance type needs to be scaled up and down just to be a little bit more optimal. So we take care of not just managing the cluster for you, but also upgrading the node instance type and the version upgrades as well. This is an extremely humbling statistics for us. CNCF runs a survey every few months, and then they seek what is their primary choice of container platform. And in addition, where are you running that container platform? So this is really a shout out to the community that is in a fantastic work up until Amazon kind of announced EKS. There are a variety of ways by which you can run Kubernetes cluster. And that all is existing in the community without really a lot of support from Amazon in that sense. But we are a very customer-obsessed company. 90 to 95% of our roadmap is driven by customer demands. So our customers have been telling us, run Kubernetes for me. We would love to, we manage our clusters, but this is an undifferentiated heavy lifting for us, and we would like you to run the cluster for us. So this number is just an indication that our customers were really asking us to run the cluster, and that's the reason we announced the managed Kubernetes service. Now, we did build this service thinking through this very deeply, and as we do with all of our services. So let's go through the core tenets of why we build this service and how are we looking at it. So the very first tenet itself is it's a platform for enterprises to run production-grade workloads. Some of our most innovative, some of our customers who are extremely large and very innovative have told us that we would like to run a huge enterprise workload on this cluster. And that's sort of one of the biggest tenet over here, that we want to give you the abilities that you are aware of coming from AWS. Whether it's reliability, whether it's availability, whether it's scalability, whether it's performance. We want to give you all the abilities when you are running a Kubernetes cluster at an AWS scale. The second core tenet is about providing a native and upstream Kubernetes experience. One of the reasons, among many, why Kubernetes is so popular is you can run it on your desktop, you can run it on premise, you can run it on different cloud, in a variety of ways you can run it. And then if you're running upstream Kubernetes, you are learning a particular skill. You are using CubeCuddle. It's CubeCuddle, not kubectl. If you're using CubeCuddle, then you're applying your manifest to the cluster. I think we can debate about CubeCuddle, kubectl later at the AWS booth. But you know how your manifest is designed. You apply that manifest using CubeCuddle. That is exactly the experience we are bringing to Kubernetes. There is no forking. There is no internal branch of Kubernetes being maintained. We want to bring your upstream experience straight up to a Kubernetes cluster running as part of EKS. The third tenet. Now, a lot of our customers, they would like to leverage the integration with different AWS services. Not required, because if you're running Kubernetes in a variety of ways, then you may want to run it as is. But if you need integration with AWS services, we will provide a seamless integration. So think about services like CloudWatch. Think about services like CloudTrail, Private Link, VPC networking. All of those integrations are going to be provided to you out of the box, which allows you as a customer to not worry about those integrations. And that's just only a start. We would love to hear from our customers, from each one of you. So stop by the AWS booth or during a Q&A time, shout out your requests. We would love to take that feedback. What is it that you would like us to work upon? And what are the other integrations with different AWS services that you would like to see? Because that is what is going to drive our roadmap. And last but not the least, this is the tenet that I am the most excited about, working in the open source team. So Brandon is part of the service team. I'm part of the open source team. EKS service team is going to actively contribute to the upstream experience. As I said earlier, there is no internal branch or fork of the Kubernetes upstream up here. So whatever patches, fixes, issues that are going to be applied are going to be done in an upstream manner. And we are actively hiring. So this is my pitch. If you want to talk, if you want to work for Amazon in the Kubernetes open source land, come talk to us. We would love to talk to you and come work for us. So let's talk about it a little bit. As an EKS customer, what do you really get? Well, you get an EKS cluster. How do you create an EKS cluster? There is an AWS CLI by which you can create a cluster, of course. If your account is whitelisted, then you also get a console. Through the console, you can create a cluster as well. So literally create cluster, and it creates a cluster for you. And in terms of cluster, as we talked about, the control plane is all fully managed. Then once the cluster is created, you bring your worker nodes. And those worker nodes are provided as an army, and we'll talk about that in a second. But then you apply a CloudFormation template, which then attaches your worker nodes or your data plane to the control plane. So that kind of makes your entire EKS cluster. You can launch add-ons on the workers because the master is in our account. The worker nodes are in your account. So we provide an opinionated way of running a Kubernetes master. But on the worker nodes, you can launch any add-ons that are completely in your control. So you can do what makes sense for you. The color is, I think, it's dimming. It's the last day of KubeCon, I guess. The color is dimming up. My voice is tiring, and so is the screen. And last but not the least, the whole purpose of spinning up this cluster is to launch workloads, which is exactly the applications that you have been building. So eventually, you can start launching workloads. So the process is very simple in that sense. Let's take a look at it. What do we do for you behind the scenes to make this happen, though? So you say, create a cluster. Behind the scenes, we create it's a highly available control plane. So we spin up 3 masters for you. We create a highly available etcd as well. So, and again, it's an opinionated approach that we have taken. The masters and the etcd are not co-located. That goes back to Amazon's philosophy of reducing the blast radius, so that there are 6 nodes running over there. If a single node goes down, is either the etcd or the API server, controller, scheduler kind of gets impacted, not the whole thing. That's an important part of it. We also provide IAM integration, because if you're in the AWS land, then you love that identity and access management using IAM. So you can actually authenticate with the cluster using Heptoi Authenticator that we'll talk about a little bit later. We also do certificate management for you. The worker nodes are registered in an auto-scaling group, and so are the masters, so that in case a node goes down, it can come back up again. Now, that concept is a bit different from auto-scaling your cluster, which is, again, a very native upstream experience. So if you have set up a cluster, then you can use all the native Kubernetes concepts that are available to you. And last but not the least, of course, we set up a load balancer in front of your master so that all, from your perspective, what you get is an API server, and you can talk to it directly. Now, setting up and managing a Kubernetes cluster, it requires a bit of an effort over here, okay? So what we do is, we give you a console, you create a cluster, and we give you an API server URL, and then you can set up your highly available cluster, the data plane, across multiple availability zones. You bring your workers in, you get an EKS control plane, and then you can use your standard CubeCuddle. So like if you're using 110, you can use a 110 CubeCuddle to talk to the EKS cluster and start deploying your applications. And if you're running your workloads, be it deployment, be it replica set, whatever it is, all those are now registering in your worker node. Let's talk a little bit about the EKS architecture. So how do I provision EKS worker nodes? Now, we provide you a pre-configured army. As part of that, essentially, you get a Amazon Linux 2-based army. And on that army, we have the right Docker version, the CubeCuddle version, the kubelet, and all the components that you need pre-configured for you. Now, again, that's an opinionated way of running an army for the worker node. But we understand the customers would like to run their own operating system. They would like to package additional components. A lot of our customers have told who would like to bundle additional components over there. So the way we build those armies are using Packer scripts, and those Packer scripts are going to be GA as part of the EKS GA itself. So what that means is you can use the same Packer script to create your own army using your own operating system and bring those armies as part of the CloudFormation and then attach them to the master. So it kind of gives you full control and configuration and ability to customize the army that is running on the worker nodes.
Awesome, thanks, Arun. So I apologize for Flux kicking in. My machine's confused. It says it's 5:57 a.m. Seattle time. So now you won't have to stay up too late because your circadian rhythm is disrupted. I know, I'm not going to do that. But anyway. So let's also talk about a couple of the open source projects that are that accompany EKS. So the first is the Heptoi WS Authenticator. This is an open source project that basically allows CubeCuddle to also pass forward IAM identity information with every CubeCuddle call. So we chose this approach because it is open source. This is something you could set up on your own cluster if you wanted to, but it's basically prepackaged with the EKS cluster that you get when you create it just by default. So what we wanted to do in this case is bundle IAM with EKS, but not make you use IAM for all the authorization. So in this case, IAM is just for authentication, and we actually tie into the native Kubernetes RBAC for authorization. So let's look a little bit at how we do that. So step one of this process is with CubeCuddle, using the Heptoi AWS Authenticator, it looks in the same credential chain where your AWS CLI does. So if you have your AWS config file, if you have environment variables, if you have like an IAM role set up because you're using it from an instance, it basically looks for that identity, whether it's an active profile or like in the config file, and passes it forward to the Kubernetes API server. On the back end, we have a webhook, essentially, that verifies this AWS identity and just says, yes or no, this is a valid AWS user for this particular AWS account. If you're approved, if you're a valid AWS user, the actual verification of what actions you can perform inside the cluster are validated against the RBAC system. So as an example, by default, the cluster creator gets system master privileges, right? So you have cluster admin privileges. So you can, of course, do everything that you need to do, get pods, you can describe pods, you can control everything on the cluster. But if you have an additional user in your account that tries to run the same commands, they'll be rejected because they are not in the RBAC system. So again, that Kubernetes action has been passed back to CubeCuddle, and we'll take a look at that in just a little bit. So an interesting component of this is that during the preview, one of the things that was a little bit maybe controversial is we packaged our own CubeCuddle, right? We compiled it with the Heptoi Authenticator, and it's basically just a superset of CubeCuddle functionality, and you could use it with all our Kubernetes clusters, but in order to use EKS, you had to use our custom CubeCuddle because it contained that binary in it. However, as of the release of 1.10 with the support of pluggable authentication providers, you can now just configure your CubeCuddle to reference this external authenticator binary and use the native upstream 1.10 CubeCuddle. And that's how my cluster is configured today in the demo. So we'll talk about that. Another open source component of EKS, which we are quite fond of, is our CNI plugin. When we were talking to customers early on about what should EKS do for you, there were a lot of requests to solve some of the problems with some of the existing networking approaches in Kubernetes. KubeNet, for example, kind of limited your cluster size. Some other options are maybe difficult to debug or difficult to get visibility into. So with our CNI plugin, what we wanted to do is just bring native VPC networking to Kubernetes pods. And so the CNI plugin itself is a couple of different components. There's an IPAM daemon inside of it, which is responsible for basically calling out to the VPC, saying, give me IP addresses. And then there's the actual CNI plugin itself, which does all the wiring of the interfaces and dropping those into the pod namespaces. This is the end goal here is to just give you native VPC IP addresses, so you get a flat routable network. Your pods and your instances all share the same VPC IP space. This is open source on GitHub. There are quite a few contributors, and there's a lot of work going on this right now. It's still alpha. You can test it out in COPS today, and it is provided by default on EKS clusters. And this will be something that we'll consider GA when the service is also GA. So let's look at architecturally how this works. The CNI itself is deployed as a daemon set on every instance in your cluster. And so what happens is when a workload is then deployed or scheduled to your instances, the CNI plugin, again, makes that call to the VPC APIs. So it makes an EC2 associate address call and associates secondary IP addresses to your ENIs on your instances. So after that happens, the CNI plugin itself actually wires in these secondary IPs. It creates the virtual Ethernet pairs. It puts them into the network namespace for the individual pods. And the end result is you just have routable VPC IP addresses that allow you to hit your pods directly. So there are some interesting caveats around this approach, which we always like to talk about. There's, of course, limitations on how many ENIs you can attach to instances, right? So if you're using like a T2 micro, you can attach 2 ENIs and like 6 secondary IPs per ENI. But as you get up to larger instances, you might see where you have 15 ENIs and 30 or 40 secondary IPs per ENI. So generally, the pod density that you can achieve on a given instance type tends to scale pretty well with larger instance types. So it'd be great. Take a look at that. Let us know what you think and test it out. Going back to some of Arun's earlier messaging, we are very intent about keeping EKS upstream and vanilla Kubernetes, right? I know when we announced this, there were some questions around what are our intentions with this. And we think by becoming a certified distribution of Kubernetes, you can see our conformance test results on the CNCF GitHub page. We really hope this communicates our intention here. We intend to get certified for every version of Kubernetes that we qualify on EKS. That was easier said than done early on, though, because there were some challenges to passing conformance tests for us. And we think this is kind of one of the interesting problems we've solved here. So Kubernetes has this assumption, generally, that the masters and the workers run on the same network, right? And they have direct access to each other. And this is because there's a bidirectional data path, right? So your workers reach out to the masters to access the API, and the masters invoke connections into the worker nodes to support data flows like exec, logs, proxy. All of these things treat the kubelet as the server. So in a situation where you're running EKS and you have your masters and workers in different VPCs, this presents a unique challenge. Because we could ask you to open up security groups so we can reach into your instances, so we can invoke that connection to your kubelet, but that was kind of nasty feeling, so we decided not to do that. So what this looks like to enable this cross-account networking and to support exec and logs is, first of all, for the API access from the workers to the masters, we give you a network load balancer in front of your EKS masters. This is really nice because we have, amongst other things, there's static IPs on the network load balancer. So this solves some of the problems where if you've ever experienced like a classic load balancer that's scaled up and the actual IP address behind your DNS name changed and it messed with your certificates or something like that, that's no longer a problem. So API access traverses the static IPs. But in situations where the masters need to reach out to the workers, what we actually do is we create elastic network interfaces in your VPC. But they're actually attached to our masters. So if you look at the details of one of these ENIs, you'll see that there's a different owner for the attachment and a different owner for the actual ENI object itself. So this ENI essentially just gives us a route into your VPC. And this is TLS encrypted. So anytime you invoke exec and logs, it traverses this cross-account ENI. And it is an encrypted data channel. So a little bit more about that. We configure every Kubernetes cluster, every EKS cluster, as its own CA. So we're using the built-in Kubernetes CA mechanism, and we generate public and private keys upon cluster creation. When kubelets check into the cluster, they issue a certificate signing request. and we return a server cert that it installs. And then nothing super fancy here, but we do have certificate rotation on that, so you can ensure that the cert that the kubelet is running is up to date and secure. So that about wraps up our slides. We're doing OK on time. And I'm going to switch over to a demo real quick. What I wanted to do was just run a describe cluster. And so one of the can you guys, oh, what? Nope. Let's do this. I have a really nice background. I want to show this. How about that? Cool. So this is my described cluster. It's important to know that the EKS APIs themselves are actually relatively minimal. We don't want you to have to interact with our APIs more than you would have to interact with CubeCuddle, right? So you can keep your native Kubernetes tooling, and the additional overhead from EKS is really, really minimal. We wanted to keep this a very thin shim. So the things that are important to look at here, there's some metadata on this cluster. We can see that there are 2 subnets assigned to it, and this means that there are subnets in my account where the EKS masters live in the EKS team's account. This is where it creates ENIs, and this is where it expects the worker nodes to actually be running. So these subnets are the ones that we have access to in order to invoke connections into your worker nodes. There's also a ARN for a role, where this role gives us the ability to do things on your behalf in your account. So for example, when Kubernetes needs to create a load balancer, we use this role to assume those permissions and then take those actions. Other interesting things, perhaps, desired master version 1.9. We only specify to the minor version because we're automatically going to keep this on the latest patch version that's applicable to our environment to make sure that there's no outstanding CVEs or security issues. There's a security group assigned, and this is the security group that controls ingress and egress from these control plane ENIs that we create. And then finally, the master endpoint. This is perhaps the most critical detail, right? This is how you reach that Kubernetes cluster. You actually configure your CoopCuddle to point to that. So if we do a CoopCuddle version, something that is interesting to point out is that this is the upstream 1.10 CoopCuddle client. And it's actually pointed at the Heptoi AWS Authenticator, and I'll show you how that works. This is backwards compatible, so the server version here, the EKS cluster, is running 1.9, and there's no problems with those working together, as far as I know. And so let's see. If we do a CubeCuddle config view, the interesting part here is the username for my EKS cluster. References these arguments here, references this external Heptoi Authenticator AWS command. So every time a CubeCuddle command is executed, this binary is executed as well. Well, almost every time. What else was I going to do? Let's do this. So I have a cluster running. Do I have Wi-Fi? There we go. So I've got a few nodes checked into my cluster here. We're running an actual EKS-produced AMI. This is the AMI Arun was talking about. This is our EKS-optimized AMI. We maintain this, and we release this continuously as there are patches needed on the underlying OS or to the kubelet or any of the, basically Docker, kubelet, any of the binaries that we package in that OS. Let's see what's running on my cluster here. So far I have a couple of Redis pods. I have Weave Scope running that I deployed via Helm. And we can get some logs from this particular Redis container. We can also see that Helm is working, and Helm works the same way that CubeCuddle does, where it references that external binary. And we can see that we have a couple of things running via Helm. Let's see if we can deploy Datadog via Helm. Do I have that running now? Goodly Shrimp is an excellent name. Awesome. So Helm is working there. So minimal demo. Things work. This is Kubernetes. And if we go back to our slide, go back to my awesome background. We can talk about, use this as a prompt for our Q&A. So will Thing work on EKS? Generally, the answer is yes, but if you have specific questions about these things, we'd love to answer them for you in the few minutes that we have left.
So if you have a question, yell. Yeah, right.
So we're talking about certificate management, and right now it's pretty complicated. It needs a lot of coordination, for example, to change the key that signs the tokens, or even change the CA, which is really like really involves some downtime on your control plane. So how can I coordinate that with the EKS?
So you want to manage the certificate rotation for the Kubernetes CA?
Well, for example, the CA or the tokens. I think it's easier to do.
Yeah, today only we manage that for you. So for you to provide certs, maybe via something like ACM is a goal for us long term. But there's not a quick solution to that right now. I agree, there is some difficulty in that.
There was a hand over there, yeah.
So each managed service imposes some limitations, right? For example, like Elasticsearch service has collected listed APIs of Elasticsearch. So what are the limitations of Kubernetes service here? What can I do with Kubernetes if I put that on my EC2 instance, which I cannot do with EKS?
Yeah, I think that's a brilliant question. The question is, if I'm running Kubernetes cluster by myself on EC2 instance, let's say using kops, versus I'm running EKS cluster, what is it that I cannot do? I think that is the thing where I'm pretty stoked, because we are providing 100% upstream experience, where anything that you can do on a cluster created using kops or any upstream experience, you should be able to do it on the cluster created using EKS. However, in a cluster that you have created by yourself, you have full control of the master. So for example, you can specify the API server switches, anything that needs to be done specifically on the master, you can do that. In our case, because the master or the control plane is running in our account, so you don't have access to the master, those EC2 instances don't even show up in your account, so you cannot SSH or do anything over there. So I think that's sort of the biggest difference that I would say that you need to think about. And if you don't care about how the master is managed and all those things, workers are in your accounts. If you need to run a daemon set, then you can easily run it in your worker nodes.
Right. Something else to add to that, for example, is we don't have API feature or alpha features enabled on the masters. So, for example, if you want to take advantage of alpha features, you would need to still run your own cluster for the time being, right? So, slight differences there.
Are there any plans to support Windows workloads?
Would you like us to? Who's a core maintainer here who wants to talk about Windows support? We will be supporting Windows as soon as it's something that is a beta feature, for example. There's been several customers asking us about Windows. It's clear it's important to the community, so I don't see why not.
Are you managing, or how are you managing provisioning IOPS, say, for etcd nodes?
The question is, how are we managing provisioning IOPS for etcd nodes? We are using, so everything that is in EKS is built on AWS today. And so etcd instances are just EC2 instances running provisioned IOPS volumes behind them. I think the question is kind of, what happens if you start to run out of IOPS? We'll be monitoring for that, and the answer is yes.
The plans to be able to run workloads on Fargate?
Check out our virtual kubelet pull request as of a few days ago. We've written a Fargate plugin for virtual kubelet, so this is actually kind of an experimental approach. Without going into too much of a rabbit hole here, the concept of removing the node from Kubernetes is kind of complex. So we are hoping to start getting the community to think more about this virtual kubelet approach, and we think it definitely has legs. There's some collaboration between us and some other folks in this space. We'd love to see how this works out for you, and of course there's some work to do to make sure Fargate can support the full scope of Kubernetes APIs, which it doesn't today. But we think eventually we'll get there, and this is probably the right way to go for us right now. At least it's one option for us.
Yeah, just to add to that, Fargate we announced at reInvent last year, and essentially Fargate is a way by which you can run your tasks, which is a ECS language, our native orchestration technology, or a Kubernetes pod eventually that you'll be able to run in future without being able to worry about the cluster itself. So you say, from your perspective, you just want to bring a pod spec and say run it, which is a deployment or whatever it is. So at reInvent, we announced the GA of Fargate supporting ECS, which is our native orchestration technology. And then we also announced our intent for Fargate plus EKS. That's going to be coming up in the future. The hand here. Yeah.
Will I be able to specify which flags
Will I be able to specify which flags the API server will use or cannot use? And that's the approach that we have taken, wherein it's an opinionated approach. And we are constantly talking to our customers on what works and what doesn't work for them. But at this point, those flags are not exposed. Let me actually come back to you. There was another hand over there. Yeah.
Sorry if you said this, but can you talk about the timeline for making this GA and what the criteria are for
That is an incredibly aspirational question. His question was, when are we going to have this GA? So soon.
And if you want to sign up for the limited preview, you can go to aws.amazon.com/EKS. 2018. The timeline for GA is 2018.
do you expect anybody who signs up to the preview mode, or is it just a few people?
No, you can sign up. We are constantly onboarding customers, whitelisting them. So yeah.
Are any plans to make the managed etcd GA?
Well, I mean, etcd, managing etcd by itself is not for the faint of the hearts. So at this point, what we are looking at purely is to have etcd behind the scenes, not be even exposed over there. But that's a good customer feedback. Do talk to your account manager. Eventually, that's what helps us decide what our roadmap is going to look like and what are some things that we can do. Let me actually, yeah.
Arun, can you ask me when you would use that etcd?
Yeah, what would you use managed etcd itself for? Would you run your own Kubernetes masters?
Sure. Yeah.
What
I want to go to the back of the room and see if there are any questions over there. Yeah, over there. Yeah. Yeah, the question is around CubeIAm. That's what they're using. So with Heptoi Authenticator that Brandon talked about, we give you the ability to authenticate to your cluster. CubeIAm, as much as the prominent it is, that's sort of one of the primary ways how customers have been using to assign an IAM role to a pod and the capabilities to the pod. Now, there are issues with CubeIAM. There are other approaches like KIAM, but we don't like some of those approaches. The long-term road, the way we are thinking, is something like Spiffy and Spire that was talked about in the earlier keynotes. That's going to provide a portable container identity. So that's sort of the approach we are looking at it. There is no strong recommendation from us. And I think one of the cool benefits is because it's 100% upstream experience, whatever is available in the upstream, you can leverage all the innovation as part of that for EKS as well. So the question is pricing.
Pricing will be available when the service is GA. Oh, so the question is, do I have to use IAM for authentication, right? So for other IDPs, the solution would be to federate with IAM. Because we're an AWS managed service, IAM is the de facto standard for us.
Any question there? Question here? Is it going to be possible to use Calico as a network supplier? That's actually a great question. As part of Kubernetes uses CNI, and we have our own AWS CNI plugin that is fully open source. So that's the CNI plugin that we're going to use, although we are working with Calico very closely. And as part of, if this was like a 3-hour session, we could have gone into all the details of EKS, but Calico would be available in EKS Cluster to give you at least the firewall capability. But you don't have the capability to choose the networking plugin by itself.
When talking about ENIs, so is it like how will the metric for auto-scaling work? Because ENI will limit the number of scales on the node level. So how are you going to solve that?
Right, so the question is, ENIs impose a resource limitation on your node, so is autoscaling aware of that? In this case, the scheduler, we've written an admission controller to make sure that the scheduler is aware of how many, based on an instance type basis, how many total IP addresses are available, and this is just another resource constraint. So the goal is to make sure that the scheduler, if it tries to place a pod on a node that doesn't have sufficient IP address capacity, will fail, and then if you have something like the CA that's autoscaling reactively, should work based on that. So the question is, how's our support for online resizing of PVCs with EBS? So that's an interesting question. We haven't done anything unique in that space. It's just the same volume provisioner that's in the open source space. We have talked quite a bit about the container storage interface this week, and I know there's a bunch of efforts to pull the volume provisioner out of core Kubernetes. So this seems like a nice opportunity for us to contribute some to that and try to address some of the issues in the volume provisioner in the future.
Now, CSI is not even an alpha feature at this point in upstream itself, so how it evolves over there, we're definitely watching that space. Anything in the back? Yeah, last person.
You said that the user can use custom AMIs. How do you know the ways?
Yeah, so the question is, the users can use custom AMI for the worker nodes. As I said earlier, the way we are creating those AMIs is, for example, using Packer scripts. So those Packer scripts are going to be open source as part of the GA. So you can take exactly those Packer scripts so that you understand what components and how the army needs to be configured. So you can bring your own operating system, bring those armies, and then essentially the way those worker nodes or those armies are connected to the master is using CloudFormation template. So you will just alter the CloudFormation template, plug in your own armies, and attach them to the control plane. That's actually a great question. Will you provide ability to provision, other managed services? 3 days back, actually, I'm glad you asked that question. 3 days back, we wrote a blog about Open Service Broker. So take a look at that effort that was started by Cloud Foundry, and that allows you to provision AWS services as first-class Kubernetes resources. Now, at this point, the blog talks about how you can use Open Service Broker to provision SQS and other services. But that's running on a COPS cluster that you manage. But again, that's an effort that we are closely watching. We are actually contributing back to it. So once EKS goes GA, if that is a feature that matters to you, do let us know, and we'll start integrating that as part of EKS itself.
Yeah, I think there's quite a few services that are available in the Open Service Broker API already. There's S3, RDS, SQS is one of them.
Yeah,
I think there's like 6 or 8 of them right now.
Yeah.
Node auto patching, is that something you'll do automatically, or is that down to the customer in the cluster?
The question was node auto patching. So that's not something we will have by GA. You'll still kind of have the bring your own node approach. But we will, of course, release AMIs continuously. So it could be as simple, if your apps are all stateless, right, just updating the launch configuration for your auto-scaling group and rolling those out. So there's also an SNS topic you can subscribe to be alerted when there's new AMIs available.
So unfortunately, we can keep going for as long as you want. And there's a lot of interest. We would love to keep going. Thank you very much. If you would like to know more about EKS and the roadmap and what's coming up, we would request you to stop by the AWS booth, get your badge scan. We'll put you on the list so that you can get the latest and the greatest updates about EKS.
Thank you so much, everyone.
Thank you so much.